So we often hear about blockchain as this kind of digital fortress, right? It's super secure, totally self-contained, but also really isolated. And that begs the question, what good is a fortress if it can't interact with the world outside its walls? Today, we're diving deep into one of crypto's biggest, most fundamental challenges, the Oracle problem. On the surface, this seems like such a simple question, doesn't it? I mean, a smart contract is just code. Why can't it just ping a website and grab the price of Bitcoin? Well, the answer to that question actually gets to the very heart of what makes a blockchain tick, and it reveals a massive hurdle for the entire Web3 space. You see, you have to think of blockchains as these intentionally designed walled gardens. All of that incredible security and integrity they have, it comes from being completely sealed off from the messy, unpredictable outside world. It's a feature, not a bug, but it definitely creates a major limitation on what they can actually do. And the key word on this slide, the one that explains everything, is deterministic. All it means is that a smart contract has to produce the exact same result for every single person on the network, every single time. If it could just pull in outside data that's constantly changing, like a stock price, that guarantee would be shattered. That isolation is critical, and it leads directly to what we call the Oracle problem. This really lays it all out, the two separate universes we're trying to connect. You've got the on-chain world, it's perfectly secure, everything's verifiable, but it's totally isolated. And then you have the off-chain world. You know, the real world. It's real-time, it's dynamic, and frankly, it's messy. To build the kinds of apps we all want, we have to find a way to build a bridge between these two. So the first idea that probably pops into your head is, well, why not just have one trusted website or API feed the data to the blockchain? It sounds quick, it sounds easy, but it is a massive trap. It's a centralization trap, and it completely defeats the whole purpose of using a decentralized blockchain in the first place. Think about it. If you rely on just one source for your data, you've just created a single point of failure. You've reintroduced the very problem blockchain was built to solve. That one source can get hacked, it can go down, or worse, the owner could just straight up lie and manipulate the data for their own gain. All of a sudden, your trustless system is now trusting one single, very fallible entity. And that leads us to this crucial, unbreakable rule. The solution for getting real-world data onto a blockchain has to be just as decentralized and secure as the blockchain itself. You can't build a digital fortress on a foundation of sand. It just doesn't work. And this is where the hero of our story comes in, Chainlink. Now, Chainlink isn't just one Oracle, it's a decentralized Oracle network. It's this incredibly robust, secure, and really elegant bridge that was built from the ground up to solve this exact problem without making any compromises. The way it works is just beautiful in its simplicity. First, a smart contract says, hey, I need the price of Ethereum. Then, a whole network of independent computers, or nodes, all go out and fetch that data from multiple different places. Each node submits the answer it found, and then, this is the key part, an on-chain contract gathers all those answers, finds the consensus, and delivers that one single verified piece of truth back to the smart contract. And this right here shows you the real magic. So what happens if one node is acting up, or is maybe even malicious, like node 4 here? Its price is way off. Well, the network doesn't even flinch. The aggregation contract sees that that number is a huge outlier compared to all the others. It simply throws it out, and then it takes the median value from all the honest nodes. The end result is a single, tamper-proof data point that the smart contract can trust completely. Okay, so we've solved this big technical problem. But what does that actually mean? What does this unlock? What can we build now that we have this secure bridge to the real world? Well, as it turns out, the possibilities are pretty incredible. The biggest and most obvious impact is in DeFi. You have these massive lending platforms managing billions of dollars in collateral. They absolutely need to know the real-time, accurate price of assets to avoid disaster. Chainlink's price feeds are quite literally the backbone holding up this entire industry, allowing these platforms to operate safely. Or think about something like insurance. You could write a smart contract that automatically pays out to a farmer if Oracle data from weather APIs confirms that rainfall in their specific region dropped below a certain level. There are no claims adjusters, no paperwork, no delays, just an automatic, trustless payout triggered by real-world data. It's a game changer. And hey, it's not all just about finance. In the world of on-chain gaming and NFTs, fairness is everything. How do you prove that a rare item drop in a game or the traits on a newly minted NFT are truly, genuinely random? If the developer can secretly control the outcome, all the trust is lost. This is where another amazing Chainlink service comes into play. It's called the verifiable random function, or VRF. It provides a source of randomness that is cryptographically proven to be fair and impossible to predict. It's a guarantee that ensures every player and every collector has a fair shot, and that the game can't be rigged. So let's just zoom out for a second. We've gone from a totally isolated blockchain to one that can securely and reliably react to real-world prices, weather data, and even true randomness. This connection is absolutely fundamental, and believe me, it's only getting stronger. When we look ahead, this tech is expanding like crazy. We're seeing cross-chain oracles that will connect not just one blockchain to the real world, but all blockchains to each other. Major companies are starting to use it for things like supply chain management. We're even seeing the start of decentralized marketplaces where anyone can securely sell their valuable data to smart contracts. So if you take one thing away from this explainer, let it be this. Oracles are the missing piece of the puzzle. They are what transforms smart contracts from being these simple on-chain curiosities into powerful, dynamic programs that can actually interact with and respond to the world around us. They make the real world programmable. And that leaves us with one final and really exciting question. Now that we can securely hook our code up to real-world data, to real-world events, the real world itself has become programmable. So the only question left is, what are we going to build next?